All right, so today we are going to start our discussion of arcs and chords, and we're going to do 2 lessons because you guys get to go on a field trip on Friday, whether it be choir or Macbeth or something else, or the ones that are lucky ones that have to stay here with me. Those ones, are stuck with me. So, so a chord is a segment with endpoints on the circle. It divides a circle into 2 congruent arcs. Or not 2 congruent arcs, sorry, just 2 arcs. We're not talking about semicircle right now. The arcs that it would cut it into is, if we're looking at this, PQ is a chord that contains arcs PQ, which is a minor arc, so we use 2 letters, and I could choose a lot of different letters here. I'm going to do PAQ, and that's a major arc, so that's why I had to use 3 letters. So it contains, so it contains those 3 letters there and the 2 letters there. So it contains this arc here and this arc here. What do you notice the 2 arcs form? A circle. So chords basically chop the circle, whether it be even or not, but it chops the circle and just cuts it so that it has 2 different arcs. So a diameter is a chord that intersects the center of the circle. It divides the circle into 2 congruent arcs because it cuts it into 2 semicircles. So that's why that's the case. So we know that AB is a diameter with arcs APB congruent to arc ACB. So I'll highlight those for you guys in a second here. So AB is my diameter. APB is this arc here. Boys, stop. And ACB is this arc here. So if you're looking at the red and the yellow, do you see how those are the same? So if it's a diameter, if your chord is a diameter, it goes through the center. So O is my center, AB is my diameter, and it cuts it into APB and ACB, which forms a whole circle, but these ones happen to be congruent, unlike these 2. And then finally, any chord which is not a diameter divides the circle into a minor arc and a major arc. As we noticed with our first one, somebody said that one of the arcs was really big. PAQ is very big. So we are talking about PQ and arc PAQ. Okay. Yes, some kids finished the first worksheet before we even started the other one. All right. Congruent corresponding chords theorem. In the same circle or in congruent circles, meaning they have the same radii or diameter, 2 minor arcs are congruent if and only if their corresponding chords are congruent. So this goes both ways. So since AB is congruent to CD, we can imply arc AB is congruent to arc DC. We're not doing any more proofs for the year. Don't worry, we're done with those. There is another construction at some point. I'm not sure when, though. It also goes the other way. Since arc AB is congruent to arc CD, we can say that the length of chord AB is congruent to the length of chord CD. So that goes both ways there. That's what if and only if means. Remember, that is like, what did we call that? A biconditional statement at the beginning of the year, right? You can read it forwards and backwards, if and only if. And sometimes we wrote it with IFF, if you remember that. So in the diagram, we know that those two circles are congruent. They have congruent radii. So we also know that FG and JK are congruent, and the measure of JK is 80 degrees. So what would the measure of FG be? It would also be 80 degrees. So we would say, and you don't have to write all of this, you would just write 80 degrees on your homework. But since FG is congruent to JK, arc FG is congruent to arc JK, which means that FG, the measure of FG, equals 80 degrees. Remember, on the notes, I do a little bit more explanation than you would do on your homework. So if you go back to look at them, you actually know where the heck the 80 came from.
Are there any other geometry class? Oh, wait a minute. Yeah, I was in that one. I was about to ask, are there any other geometry class?
Yeah, Miss Brisbane has one. And then Herbig and I both teach 1/3 hour. I think those are the only ones that are doubled up, though, maybe. No. I'm not, though.
No, she's not. I already yelled before it.
Wait, I had to change this scroll.
You do.
Scroll's awesome.
She is awesome. Kroll is really awesome. You guys, so we'll be getting a new teacher in our, so you could also have Herbig. We know that AB is 110 degrees. So we need to find the arc measure of BC. So what do we know the measure of BC would be? 110. So why is this the case? Well, since we know, yes, AB is congruent to BC, they're both 9. Good. Arc of AB is congruent to the arc of CB. So that means that the measure of CB equals 110 degrees.
Can you request not to have a teacher?
You cannot request teachers at all. Okay. In the next one, it says if AC, we know that AC here is 150 degrees. If AC is 150 degrees, we need to find the measure of arc AB. What do we know about AB and BC? We know that these two are the same, right? Because AB the chord AB is congruent to chord CB, we know the arcs are congruent. So how could we figure out, yeah.
You subtract 150 from 360 and then divide it by 2.
So we know there's 360 degrees in a circle. But that means that this is the measure of arc ABC. Do you guys see that? So the measure of arc ABC is 210 degrees. But we don't want ABC, we just want AB. So as Ian said, we will divide by 2. And we would get the measure of arc AB is 105 degrees. I'll just leave it right here. You can see it. Nobody should take it then. Okay. Don't touch it. What? Oh yeah, don't touch it. All right, guys, next one. There are 2 more theorems here that you guys will need to know for the second worksheet. This is super important and kind of confusing. So, congruent corresponding chords theorem says if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So, since F, D, and EG are perpendicular, and EG is a diameter, we know 2 things. 1, FH is congruent to HD, and arc FG is congruent to arc GG. So for this to be true, it needs to be a diameter perpendicular to a chord, which means it needs to go through the center of the circle. And then the converse is also true, which means the flip of that is also true. If one chord of a circle is a perpendicular bisector of another chord, then the first chord is a diameter. Do you see how there's no center marked here? So we cannot assume that SQ is a diameter. We need to be able to prove that it's a diameter. So since TP is congruent to PR, and since PR is perpendicular to SQ, we can imply that SQ is a diameter. So these 2 will be used on your worksheet, not your first worksheet, your second worksheet, so you're not going to want to put your notes away, guys, because the second worksheet contains stuff from this note packet too. So it says, use the diagram to find HQ in the measure of HQ. So, or HK, there's no even Q there. Okay, so we know that JL is a diameter and JL is perpendicular to HK, which means that we know that this is congruent to this, and these 2 things are also congruent. So, those are the 2 things we know, which will help us find the information that it's asking for.
Which bear is best?
Which bear is best?
Yeah.
What?
What are you talking about?
Polar bear.
I agree. The polar bear at the St. Louis Zoo.
Black bear.
What is this even from?
Well, why are polar bears extinct?
Okay, we're done with this conversation.
Black bear.
So that means that H. Now you're doing The Office. Okay.
That's what it was.
I couldn't figure out where you're going from. HN is 7, which means that HK is 7 plus 7, right? Which means it is 14. We know that to get to arc HK, we know that the arcs are congruent. So 11x is the same as 70 plus x. So x equals 7, which we can then substitute back in to find the measure of arc HK. Well, arc HK is 11x plus 70 plus x. So we can substitute in 7. Means the measure of arc HK is what? Somebody say it. What did you say? Wouldn't it be 158? 154? Okay. Right, because 7 plus 7 is 14, so it would be a 4 at the end, and then 7 and 7 is 14, so that's 15, yeah, okay. Sorry, I had to, think, do that too much. Okay, so let's finish up this last slide quicker. I'm not going to write as much information down, and then you guys will have some time to work, and then we'll start notes probably between 8:30 and 8:35 for the second one, and go from there. Oh, I can go back. Sorry. Let me know when you're ready.
How's it? Oh, okay, okay.
Do you see it?
Oh, wait. Yeah, I have it right here. I thought you were...
I'm still on this one. You're on the next slide.
Yeah.
All right. So we are just finding CE. What do we know about FE? Since BD is a diameter and it's perpendicular, what do we know about CA and AE? That's not trash. So what do we know about CA and AE? So that means these are both 5. So CE is 5 plus 5, which is 10. Why are they both 5? So why is this the case? If you have a diameter, which BD is a diameter, do you see how it has the center circle it's going through? So since BD is a diameter and it's perpendicular to the chord, we know it bisects this. So that's why these are congruent.
Oh, I thought you drew that.
Oh, it's because I'm using blue as well. Sorry. I was like, what are you talking about?
I'm way too tired.
All right. So again, since BD is a diameter and perpendicular, we know that our arcs are congruent. So we can say 9x equals 80 minus x. But we need to find the measure of arc CE, which is 9x plus 80 minus x. So I'm going to substitute in 8. And get 144 degrees. So what questions do you guys have?